Hello, my name is Steve Olson. I'm the manager of training services for Mesa and an Autodesk certified instructor. Recently we had a support call from a customer that wanted to flatten out a cylindrical shape that was done in sheet metal that had a helical cut or seam in it. So thought it was a neat workflow, so I wanted to show that here. So the first thing I'm going to do is I'm going to start a sheet metal component or sheet metal part. Okay, now my part, what I'm going to do is I'm just going to start a 2D sketch like I normally would. And in this case I'm going to make a circle. I'll say its OD is 5. And then I'll make the inner wall here. And this is going to end up being an extrusion, which is a little bit different when you're using sheet metal. But I'm going to do it in a particular way here. And then for the wall thickness here, I'm going to use the thickness parameter from the sheet metal environment here. So that way it's going to use that. So if I change the wall thickness, it will that will get updated here. So I'm going to finish my sketch, and I'm actually just going to use a regular extrude, even though it's not a sheet metal function, but it's going to help me out here. So I'm going to go the other direction. I'll just go 10 inches. This is kind of what I did when I had that support call the other day to kind of just figure out if this would work or not, and it was a neat workflow. So I'm going to go ahead and say OK to this. So now I've got the cylinder that I want to basically cut a helical around it and then create my flat pattern from that. So what I'm going to do here is I'm now going to go back to my origin, my XY plane, or actually the XZ plane in this case, and create a sketch on that. Use my F7 to kind of slice my graphics. And the first time I did this, I actually kind of didn't quite get the right result. But in this case here, what I'm going to do is I'm going to tell it to project cut edges. That way I get both the inside-outside wall here. This actually works better if you do below the initial wall there. And I can just make a collinear here and here. So basically the width of that wall, and then the height here is just how high I want this to be, and maybe I'll just make it like 0.01 or something like that, just something really thin, just enough to get that separation. So now the other thing I need to do is, well, now that I have that, I can now go into my coil command, tell it I'll pick my profile, tell it it's going to be using the y-axis. Oops, I'm sorry, not the y-axis, the z-axis. So basically what's running up and down through the middle of that part. I'm going to tell it it's a cutting operation, and for my size I'll use, and I can use any one of these here, but I'm going to go with revolution and height. I know I've got a height of 10 here. Oops, I'm going to have to flip this over the other direction. Back to my coil size, I would say maybe I want like 5 revolutions or something like that, just whatever I need my values to be. So now I say OK. So if I zoom in here tight enough, I should see that I've got this. It's pretty much ready to go. One thing I did forget to do though is if I look at the top here, I didn't quite leave the entire part here, so that's going to end up causing an issue. So if I go back to my coil, edit my feature here, and just add a little bit to the height, like maybe even like 1/4 of an inch, just something to kind of get so it exits out the top and I have a gap there. If I don't have that gap, it's not going to flatten the way we expect. So now I can just should be able to go to create flat pattern, and this thing should flatten out nice and neatly there for me. So again, pretty neat workflow. I thought it was pretty neat, so I figured I want to share that with you folks out there. So thank you for watching. Thank you for watching this video. If you have any questions or comments, please feel free to reach out to me at my email address on the screen. And again, thank you for watching.